Hello everyone, I hope you're keeping well and keeping safe. I have a question that I would like us to have a look at today, and this question is one of the questions that you will find in most of the question papers, either for semester test 1 or in your main or supplementary examination, and so it's very important if you can understand what's going on here and to get a handle of how these values are determined or calculated. The question says, consider the following information about three atoms of an element. So here we have carbon 6, carbon 12, carbon 13, and carbon 14. So the element here is carbon, and there are three variations of carbon. Now let's look at the question 1.1.1. It says, how many neutrons are present in the atom of this carbon here, carbon 14? Now, there are two numbers you'll find here, the subscript being 6 and the superscript being 14. What the subscript at the bottom here represents is the atomic number. And what the superscript at the top here represents is the atomic mass. So if you want to find a neutron, how do you calculate the neutron from here? To get a neutron, you have to understand that the atomic mass is equal to the sum of the proton and the neutron. So if you add the proton and the neutron, that gives you the atomic mass. And how do you find the proton? Very interesting. You have to understand also that the number of proton is equal to the atomic number. What is the atomic number here? The atomic number is a number at the bottom here, the subscript, that is 6. So if 6 is your atomic number and 14 is your atomic mass, how do you find the neutrons? If proton plus neutron is atomic mass and proton is 6, it then follows that your neutron will be the atomic mass minus the number of protons. So 14 minus 6, and that gives you 8. And that's how we got 8 here. Atomic mass minus the number of protons will give you the number of neutrons. Because if you add the neutrons and the protons, that gives you the atomic mass, which in this case is 14. So our answer here, number of neutrons is 8. Now to the next question, 1.1.2. How many electrons does the atom of this carbon here contain? And this is carbon 13. How many electrons does it contain? For you to know the number of electrons, you need to know the number of protons. And to know the number of protons, you need to know the atomic number. Remember we said the atomic number, which is given here being 6, is equal to the number of protons. Something interesting and important you also need to remember is that the number of protons is always equal to the number of electrons. So if the number of protons is 6, and that is your atomic number, as we see here in the subscript, it then means that there will be 6 electrons in this carbon. So the number of protons is equal to the number of electrons, and if the number of protons is 6, then there will be 6 electrons, and that is how we got 6 here. Which leads us to the next question. How many protons are present in the atom of carbon 12? Carbon 12, because this 12 represents the atomic number. Now, for this carbon here, the number of protons is always equal to the atomic number. And since our atomic number here is given as 6, it means that the number of protons is what? 6. So that's how we got our 6 here. The next question, 1.1.4, says, what is the atomic weight of carbon 12? Now, this is also very interesting. To understand atomic weight, you need to understand isotopes. which we'll talk about shortly. But here we have 6 as the atomic number, which is the number of protons, and we have 12 as the atomic mass. Now, how do you find the atomic weight here? Atomic weight is generally considered to be the atomic mass of the most abundant isotope. So in carbon, for instance, you have carbon 12, carbon 13, carbon 14, and there's a way to determine the most abundant isotope. However, in this case, we are not told which is the most abundant isotope. So, generally speaking, carbon 12 is regarded as the most abundant isotope. And so, the atomic mass of the most abundant isotope would be carbon 12. So, the atomic weight will be 12. But in the exam, we're not going to penalize you if you don't know what the atomic weight, what the most abundant isotope is, except you are told somewhere. But if we give you a question like this, what is the atomic weight of carbon 12? I expect you to use the atomic number of that particular isotope of carbon that you're given to represent the atomic weight. So, if the atomic number here, if the atomic mass of carbon 12 here is 12, it then means that for this question, you would then represent the atomic weight as 12, and that's why we have 12 over here. Now let's go to the final question, which says, what are the members of such a group of atoms called? Obviously, they are isotopes. Isotopes are those groups of atoms that have the same atomic number as you see at the top here, carbon. They all have the same atomic number as 6, but they have different atomic mass. Here we have atomic mass 12, atomic mass 13, atomic mass 14, but the atomic number remains the same across board. So which makes this group of atoms to be isotopes. So whenever you see an atom with different variations, each one having the same atomic number but different atomic mass, you know that they belong to a group known as isotopes. Okay, I hope that explains this question. Thank you.